Hi everybody. Thanks all for coming tonight. Welcome to Cloud Native London. I want to start by apologising for last month. We found out very, very last minute that we weren't going to be able to host at CodeNode, unfortunately. So thankfully, Sainsbury's has been kind enough to offer this space for at least 6 months, I think. So yeah, this will be our regular spot for at least for a little while. So what I'll do is I'll just invite Simon from Sainsbury's to just pop up and give us a quick spiel about who they are and what they do.
Okay. Blimey, hello everybody. So I'm Simon, I'm an engineering manager here at Sainsbury's. Reached out obviously to Cloud Native London when I heard about CodeNode. It's one of my favourite meetups. It's an exciting time for Sainsbury's. We're literally a new company within the group. So as of the 1st of September, we launched Sainsbury's Tech, and that's to provide a tech-first engineering function to the whole of the Sainsbury's group. So that's Sainsbury's, Argos, Sainsbury's Bank, 2Clothing, Habitat, and I'm sure I'm missing one. So a lot of change, a lot of merging between different teams and different technologies, and a really exciting time to be, working in, effectively a start-up or a new part of the business within a 150-year-old company. And I'll get it in here now. We're recruiting. We use Kubernetes, Java, Scala, Node, Python, React. So, yeah. Have a look for me, have a look at the banners. There's some flyers somewhere around if you are in the market for a job. And I'll hand back to Josh.
Awesome. All right, so do we have, there we go. Normally it would be Cheryl's face up here. It is not, it is mine. I am Josh Michelson. I am a senior platform engineer at Condé Nast. That's my Twitter, and that is the Cloud Native London Twitter. Please follow us, tweet at us, all that kind of stuff. So welcome, as always. This is our mission statement, a strong, open, diverse developer community dedicated to the cloud native platform and technologies in London. Bit of an agenda tonight. Obviously, we've already kicked off. Next will be Matt Jarvis from D2iQ, previously
Mesosphere.
Yeah, Mesosphere. Next up we'll have Jesus Escalar, I hope that's right. We'll have a bit of a break, and then we'll have Ashley Ward from Twistlock. Bit of a thanks to our sponsors. First, Technovo. Anyone from Technovo want to say something?
Hiya. It was supposed to be my colleague Cav up here tonight, and I think he's still stuck upstairs. He's doing all of the checking in, so you've probably seen him in his T-shirt. So Technova, we're a digital consultancy. We work with a lot of clients going through change, whether that's DevOps adoption or moving systems from legacy to cloud, for example. Loads of exciting projects going on. Please come and speak to me or my colleague Cav if you want to learn more. We'd love to talk about it. So the reason I'm actually meant to be on stage is talking about Meetup Mates. So I'm not sure if you've heard about Meetup Mates, but we're a group that meet up. We have a Slack channel. We communicate. So if you need any more Slack in your life, please join it. We meet up before we come to these meetups, normally about an hour before at a local venue. So if any of you feel apprehensive about coming to meetups by yourself or know people that do, also if you just want to make more friends and chat about the community, then please do come along and join us, because that's what we're there for. So it's meetup-mates.com. Thanks. Thanks, Josh.
All right, we've also got Cantino. Anyone from Cantino want to say something? 3, 2, 1. No. Okay. Pusher. Joel.
Hi everyone, I'm Joel. Does anyone here know what Pusher is, apart from the fact that we sponsor? Oh, there's some people at the back. Have you used it? No. Okay. I wasn't really expecting you guys to. So we are a developer tools company. We build communication and collaboration APIs. So we have like 3 main products at the moment, but they're not really for back-end engineers. So if you've got some people in your company who need WebSockets as a service or like push notifications as a service, that kind of thing, then we're the kind of company that might be able to help you with that. We are, like everyone, hiring at the moment, especially for cloud engineers. So if any of you are looking to do lots of Kubernetes and Terraform, maybe AWS stuff, we're doing some really cool stuff at the moment, building custom controllers and running a CI system called Prow, which is the one that Kubernetes built to test themselves. So there's some interesting stuff going on there. If you want to work on the cloud infrastructure team, come and chat to me about that.
Xmatters. Oh, we have someone from Xmatters. He's running. Everyone stare at him. Okay.
Hi everyone, I'm Nathan. Does anyone know who Xmatters is at all? There's a hand, thank you. For those that don't, my marketing team will hate me for saying this, but if you've used PagerDuty, OpsGenie, VicTops, anything like that, similar sort of thing to that, we help you orchestrate lots of actions across basically everything within your infrastructure. So everything from the dev side right through to the IT and ops side. So if you need help making those things move a little bit faster, then we're the people to go and speak to. There's a free version of the product, so go and have a look. We aren't hiring in the UK, I'm afraid, but if you can get to Canada, there's plenty of jobs going over there.
And for the first time, we also have OVH Cloud. And I'll just read what I've got here for OVH Cloud. OVH Cloud is a global cloud provider that specializes in delivering industry-leading performance and cost-effective solutions to better manage, secure, and scale data. OVH Cloud provides a smarter alternative to web hosting, emails, bare metal servers, hosted private cloud, hybrid and public cloud solutions. The group manages 30 data centers across 12 sites in 4 continents, manufacturing its own servers, building its own data centers, and deploying its own fiber optic global network to achieve maximum efficiency. Maximum efficiency. Through the OVH Cloud spirit of challenging the status quo, the company brings freedom, security, and innovation to data challenges today and tomorrow. With a 20-year heritage and a solid European foundation, OVH Cloud is committed to delivering responsible technologies as the group strives to be the driving force behind the next cloud evolution. So there we go.
Did they know about your announcement?
They weren't. I don't think they were expecting the maximum efficiency. All right, last 3. Humio. Anybody from Humio want to say something? No, cool. D2iQ. Our first speaker is going to be from D2iQ. I'm sure he can give a spiel while he's at it. And Suze. No? Okay, cool. I think we all know who Suze is anyway. Next speaking slots are November and December next year. You've got plenty of time to prepare. No, really. They are a year away, for sure. And that is... Yeah, exactly. If you start writing it now, you can... Look, you can take a slot, and we're not going to ask you straight away what your talk's going to be about. So if you just want to reserve a slot, let us know. Get in touch. And otherwise, that's it from me. And I'm going to hand over now to Matt.
Don't get too excited. We've got technical stuff to sort out first. All right, let's see where we're going with this. Okay.
That Alto just delivered the announcement with maximum efficiency.
It's going to be here. Yeah. Let's check this one over here. Yeah, that's it. It's finished now. Okay. All right. Okay, hi. So this is me. My name's Matt Jarvis. I'm Director of Community at a company called D2iQ, formerly known as Mesosphere. We are a San Francisco-based software company working in the field of cluster orchestration, so around Kubernetes and around Apache Mesos. I've been building stuff with open source software for a fairly long time, and kind of worked at that boundary between operations and development. So I want to start tonight by kind of setting the scene for what we're talking about, and I'm sure this will be familiar to a lot of folks here, but Kubernetes and I guess all other orchestration systems built around this idea of declarative state work very well for stateless applications. And stateless apps are programs that don't save client data generated in one session for use in the next session with that client. So every session's carried out as if it was the first time. And responses aren't dependent upon data from a previous session. So in practice, what that means is that we can start and stop our stateless application and it will just start executing. And in general, we'd run this kind of app behind a load balancer. And we can scale these up or scale them down just by adding or removing instances. And we can also deploy new versions pretty easily by simply replacing all of the running instances. And we can have various ordering strategies for performing those tasks. You know, we might be doing blue-green deployments for testing new versions. But fundamentally, the management of these applications is kind of binary. So we're either running or we're not. And I guess stateless applications are pretty much intrinsically intertwined with the whole move towards microservices architectures, where we connect together many very simple applications which each have a particular well-bounded function. And also with the adoption of container technologies to manage them, because they're fundamentally well suited to the patterns that systems like Kubernetes give us. We just declare we want the specific number of an application to exist, and Kubernetes will create them for us. And again, it's basically a binary thing. They're either running or they're not. And we don't have to worry about any complex operations to configure them before we start deploying. So if all applications were stateless, then the world of application deployment would be super simple. And sometimes in our industry, you could get the idea that this is the case in the era of microservices. But unfortunately, that's not actually true. And the second class of applications are stateful, where the app is retaining data or it's retaining state across its entire life cycle. And whilst older, more monolithic applications like SQL databases fit into this paradigm, there are also many architectures where the individual elements making up a particular service are actually clustered together in some way. They might be sharing state data between them, or they need to be synchronized together in some way. And this is a lot more complicated in the whole area of computer science unto itself. But typically these kind of applications have a set of lifecycle states which require logical ordering of actions in order to maintain correct operation. So in general, we can't just start and stop instances of a particular stateful app and expect it to continue to operate. We might need to wait for data to rebalance. Or there might be things like multiple steps involved in an upgrade operation. And this can apply to not only upgrading, but things like scaling, dealing with failure scenarios. And all of those operational strategies require domain-specific knowledge to manage them. So they also tend to be unique to that application. So those operations for a Cassandra cluster are very different from a Kafka cluster or an HDFS deployment. And you know, we can see when we start to look at some of the architectures of how these things work that they can look very different in practice. You know, in a typical Cassandra cluster, you've got this kind of ring idea, and then you know, in a Kafka cluster, we have these ideas of brokers. And so Kubernetes was originally very focused on stateless application architecture. One of the fundamental features of Kubernetes is that the scheduler can move pods around between agents. And that works fine for stateless apps. but it doesn't work so well for stateful things, which tend to like their storage, their networking, not to change during operation, unless we handle that in a very specific operational way. So in order to try to handle the complexities of stateful apps, Kubernetes added this concept of stateful sets, which gives us these ideas about stable networks and storage. But that doesn't actually solve all of our problems, because Kubernetes fundamentally still doesn't know what's actually going on inside pods. So as an example, we might consider rolling upgrades of nodes in a Kubernetes cluster. You know, we can imagine that we have this fictional master-slave database running in a stateful set, the node running the master upgrades, reboots, so we might lose transactions there. At this point, the database cluster may trigger a re-election, elect a new master, and when the master pod is rescheduled, it comes back up, and it may be unaware that it's come back up with a new master. That can cause issues in itself, and even if that settles then into its new role as a slave, Kubernetes sees all the nodes are back up. We may then start to roll out an upgrade to another node, potentially hitting that new master and so on. So how happy is our fictional database cluster likely to be during that operation? The answer is probably not very. But the point here about the domain knowledge of how to safely do a rolling upgrade of a particular database cluster isn't captured by the concept of stateful sets. So how do we automate and package that knowledge up? Oh yeah, no, of course, no slide deck would be complete without an obligatory Kelsey Hightower quote, which is basically saying, don't do stateful on Kubernetes at all. I'm not sure that's necessarily still true, but... So the emerging solution to this problem is the operator pattern, and operators basically encapsulate those operational tasks in code. And that can either be run when API is invoked, it can be run automatically, it can be run scheduled, so we can orchestrate those application lifecycle actions using native Kubernetes APIs. So fundamentally, operators encode that domain-specific knowledge about the lifecycle actions required for the application. How do I scale it? How do I upgrade it? How do I deal with failure scenarios? And allow you to act on that using Kubernetes APIs. So what are operators? Well, typically when we install an operator, we will likely get the operator itself, which is the code that does that management of the life cycle of that particular thing, and that's where all that domain-specific knowledge is encapsulated. And we'll also likely get a bunch of custom resource definitions which extend the Kubernetes API to address new resource types. So you add a new type that you can then put data into and instantiate. And this is a slightly fictional example of a MySQL cluster and how we might instantiate that cluster. But it's important to note that these are typically unique, so the operator's purpose-built for each application. And up until now, there's been two main ways. There actually are a couple of other ways that you can build operators, but the first one is the operator framework. This originated at CoreOS, and these days is mainly developed by Red Hat or IBM. And whilst you can build operators using Ansible or Helm charts, there is also a Go SDK. Generally for complex operators, you really need to build using that SDK. And then there's the KubeBuilder project, part of the API machinery SIG, and that's kind of focused on extending the Kubernetes API. And again, you need to write a lot of Go to build operators using that method. So ultimately, building operators can be pretty complex, well, very complex. It requires a lot of knowledge about Kubernetes internals, requires a lot of Go expertise, as well as that domain-specific knowledge that you need to about your particular application. And clearly automating simple tasks is relatively easy, but things can be a lot more difficult. So adding a replica to a database might be straightforward, but how do you fix a corrupt write-ahead log file or something similar? And the engineering effort, which goes into high-quality operators, is pretty considerable. As an example, one of the major NoSQL vendors have an operator which is very feature-rich, but it's over 40,000 lines of Go, and it took pretty much 1 man-year of effort to write it. Even something fairly straightforward like the etcd operator has around 9,000 lines of code. Let's just move straight on to that one. So at D2iQ, when we started to look at the operator landscape, it seemed like this was a pretty familiar problem space. When we started building technology around Apache Mesos, we saw a lot of developers hitting the same problem space over and over again with how do you create a Mesos framework. And a Mesos framework is ultimately pretty conceptually similar to what a Kubernetes operator does, in the sense that it's orchestrating the application lifecycle of stateful applications. So we had already created basically an SDK to allow developers to more easily create Mesos frameworks. And so when we started looking at the Kubernetes operator landscape, it seemed like there was a lot of shared possibility there for implementing the same kind of ideas. So taking those lessons that we'd learned from that space, we created the Kudo project with the aim of simplifying operator development. And Kudo is an acronym for the Kubernetes Universal Declarative Operator. And rather than implementing a custom operator for each application, Kudo provides a universal operator with the concept of plans built into it. We'll talk a little bit later about what plans are. But it fundamentally allows operator developers to define a lot of how an operator is going to work declaratively in YAML, so without writing any code. And Kudo defines a kind of framework for application-specific operational sequencing and action. So it kind of allows you to define runbooks for your particular application. It's a fully open source project, and we are actively working to build community around it. I'll talk right at the end of this talk about some of the more community-focused stuff. So in comparison to some of those other mechanisms, then you can create complex operators in Kudo without needing either deep knowledge of Kubernetes or actually writing any code at all. Just by defining lifecycle phases and actions in YAML, we can do all of that lifecycle orchestration using the built-in CRDs which Kudo provides. And Kudo is ultimately just Kubernetes. There's no DSL, there's no proprietary APIs, there's no external data store or anything like that. So as a result, it's pretty easy to learn, and it supports all the native Kubernetes tooling, customized, kubectl, etc. And it kind of maps to the same resource model that Kubernetes, as other Kubernetes resources use. I think I'll just skip that one. I basically said that already. So there's some core concepts that we need to understand when we talk about what Kudo is. So firstly, an operator in the Kudo world is the description of a deployable service represented as a CRD object. And then secondly, we have this idea of operator version, and this represents a particular implementation of that operator. It contains all the actual plans, objects, parameters for the operator. And the purpose of the operator version is to provide all the details necessary for Kudo to become an operator for a specific capability, e.g. to become a Kafka operator or a Zookeeper operator or whatever. And these are also versions, so it's for a version of that operator, which allows you basically to be able to run multiple versions of the same thing. So it's a specific version of a deployable application, including all the configuration and lifecycle hooks for deploying, upgrading, scaling. Complete definition of the application. And then instance is a CRD which ties a particular application instantiation to an operator version. And that's the actual thing we want. So it represents an actual deployment of the thing we're controlling, unique instantiation of that particular app. And when you create an instance, you can either take the defaults that are set in the operator version, or you can override parameters. And we can also have multiple instances of an operator version within our cluster. So this is to be able to run multiple versions of a particular piece of software. So you might want to be running Zookeeper 0.1, you might want to be running Zookeeper 0.2 for some reason, and you can run both of those simultaneously in the same cluster. So plans are the kind of the core bit of how Kudo works, and plans are how operators in Kudo convey progress through service management operations like deployment, scaling, upgrading. Plan is composed of phases. These are then made up of steps, and the steps are made up of tasks. So you get this kind of hierarchical thing. And typically you can configure these things with execution strategies to be either serial or parallel, depending on whether actions can happen at the same time or whether they need other actions to finish before they particularly start. So then we have this, when a plan's executed, we have this, this plan execution CRD that gets created that basically stores the inputs and the status of a particular plan, and it gives us the ability to be able to see what's actually happening within that plan. Kudo also includes a CLI extension to kubectl, and that allows us to run Kudo commands natively just using kubectl. So we can do things like install particular operators. We can look at the output of plans. We can list instances, list operators, and all that kind of stuff. And I guess this is kind of the conceptual, high-level overview of what Kudo looks like when you've deployed it into your cluster. So a set of default Kudo CRDs in the Kudo controller, various operators and operator versions that you might be running, and then using the CLI allows you to interact with the with whatever repositories you've defined in order to install your operators from. And you can install operators within the Kudo world directly from the upstream GitHub repositories. You can install them from the local file system. There's a bunch of different ways that you can do that stuff. So let's go and actually look at what this thing looks like in practice. Hopefully this will work. Let's just get that. Right, how's that, folks? Can you see that at the back? Okay, so I've just got a Kubernetes cluster deployed here in Minikube locally on my laptop, and we can see we've got nothing deployed there. And if we look at what operators we've got, basically our cluster has no idea what an operator is at this point. So I'm just going to cheat slightly here and copy and paste some stuff. I can find them out of the window. So if we want to install Kudo, I've already got the Kudo CLI extension installed, so I can just do Kudo init, which will basically go and install Kudo from the upstream GitHub repository. So now when I look at what CRDs I've got installed, these are the default CRDs that come with Kudo that allows Kudo to execute plans. And if we look at operators, so we can see that although we don't have any operators, at least now our cluster knows what an operator is conceptually. Let's just do this one in here. And we can also see we get a bunch of API resources there again that are installed by default when we start Kudo. So the first thing I'm going to do is install a Zookeeper operator. That kudo install command is just using, that's again going to install the Zookeeper operator directly from the upstream GitHub repository. Let's just have a look at that. So depending on how fast the internet here is, that may take a little while. What we can do while we, let's just see, oh no, it's going pretty quick. So, and again, we can use the kudo CLI to look at the status of that deployment plan that we're running there. And we can see for that particular plan that we can deploy this in serial. So, in this case, we need to wait for each of those pods to start running before we can do the next one. And we can see the different steps that we've got within that deploy plan. That we're going to run the first Zookeeper phase and then the validation phase just to make sure everything's working. So we can see that validation task is now running there, and that validation task is basically testing whether the Zookeeper cluster is up and running and returning correct data. And now when we do things like get operators, we can see that we have a Zookeeper operator there. And we should also be able to do get operator versions. And we can see we're running the Zookeeper 0.2.0 version. And so if we describe what that operator version looks like, and if we get time, I'll show you what this looks like on the file system in the actual operator itself that gets deployed. But we can see that everything is basically stored inside the CRD here. So we have a bunch of parameters that are used with sensible defaults at the start. Then we have a set of definitions of plans with their individual steps and tasks. And then we're going to have a bunch of things like config files that are created as config maps. And a set of stuff that's actually going to be used to create things like our stateful set, which is referencing those parameters that have been defined in our top level defaults. And that's referenced obviously using templating. So what we're going to do now that we've got a Zookeeper cluster there, I'm just going to install a Kafka cluster, and what I'm going to do with this one is actually to override one of those parameters directly on the CLI. So I'm going to change the broker memory size. That's set to 102.4 to start with, so we'll just set that to 512 for this case. And what we should see is that our Kafka cluster is now starting to deploy. And again, we can use the CLI to show what's actually happening during that particular plan. And we can also describe that instance, so that'll give us a bunch of different metadata about what's actually what we've actually deployed in that particular Kafka instance and what the statuses are of that. Okay, so we've got two running there. So let's just I'll show you quickly what this looks like on the file system. So this is the actual Zookeeper operator that we just installed. And these all have this standard layout of different YAML files. So that's the parameters .yaml, which obviously got read into that CRD that we were looking at directly in the cluster. And we also have this operator.yaml, which defines all our plans and tasks and phases. And then we have a bunch of different YAML files which are basically going to use those templated parameters in order to create the particular services, stateful sets and all those stuff that cluster actually needs in order to function. And that layout's standard across all operators that are in the Kudo repository. So let's just see what we've got to here. Okay, so now we've got a running three instance Kafka cluster, and we can just check that actually is valid. We just look at the logs from Kafka that is running there, and we can also see our different services, and then just to prove this is actually working, we'll just get a shell quickly. And I'm just going to attach to the Kafka instance and get some of the metrics that are out of it. So basically what's happened there is we've managed to install a HA Kafka cluster with an HA Zookeeper cluster in basically 2 commands, but we could have done it in 1 actually because Kudo does understand dependencies. But when we're doing this demo, we tend to split those 2 things out because it's a bit clearer what's actually happening. And if I want to change which shell am I in there? I need to do that. What's changed there? Has that update flag changed since the? Yeah. No. Right, so what I'm doing there is just telling that cluster that I now want 5 nodes of it. And we should see, hopefully if this is big enough on my laptop, we should at least see those start to deploy. Yep, there we go. So any second now we should have, I think maybe I've run out of memory in this cluster actually. But you can get the idea of how easy that is to upgrade that particular cluster. Right, so let's go back to this. Just check my slides back over there. Okay. Well, how are we doing on time?
Another couple of minutes.
Okay, cool. So I'll just run through this super quickly then. A bunch of things that are coming up on the Kudo roadmap. Some of the cool things here, this idea of pipe workflows, so we can create resources in one task and then share them with another task. Dynamic CRDs is where we can create operators where we don't need to know all the CRDs when we deploy the operator. So a use case for that might be that your operations team want to modify a particular workflow. You've already got the operator installed, so we can dynamically change the Kudo operator on the fly. So the controller doesn't have to know about all the possible sets of CRDs when the particular thing's instantiated. And there's a bunch of work going on in order to be able to effectively bootstrap Kudo operators from things like Helm charts. So to make it much easier for you to develop Kudo operators if you've already got a set of Helm charts, for example. And some work going on as well around one of the issues around doing these things purely in YAML is that YAML gets super complicated when it gets very big, as everybody who deals with Kubernetes I'm sure knows. So there's a bunch of emerging technologies around kind of changing the way we look at things like YAML. So technologies like Starlark and Q, and those are some of the things that we're looking at in the development team. There's also some work going on around being able to merge operator repositories together at runtime. So you might have in this example, you know, some standardized MySQL operator. You might have some code that's specific to a particular platform, that's stored in a different repository, and then you may have some code that's specific to your organization, and being able to actually merge all those things together at runtime so that you don't have to maintain all of that code yourself. Back to the kind of community thing before I finish. So Kudo has been submitted as a CNCF sandbox project, so we're really hoping that that we can donate that to the CNCF and widen the user base for Kudo. And if you're interested in learning any more about it, the website's kudo.dev. You can view the code at the Kudo Builder organization on GitHub. We have #Kudo on the Kate's Slack. We also have a mailing list, and we have a weekly community meeting which is done on Zoom. So we'd love more people to get involved, even if you're just want to hang out and kind of see that conversation that's going on around where Kudo's going. You know, we'd love to have you there. So yeah. I think that's pretty much it. Thanks, folks.
Thank you very much, Matt. So next up we'll have Jesus Escalar. So while we get sorted on that, it'll be just a couple of minutes. Cheryl will kill me if I don't get one of the selfies with everyone behind me. So. Everyone say cloud native.
Hi, Cheryl. Do you need to shop her face?
I had some ideas about photoshopping my face onto, but let's not go there. Do you need anything?
No. Just to make sure I have Palo.
Yeah.
That's the only.
Matt, can you please just grab the microphone?
Yeah, cool.
I can actually disentangle myself, right? Just wound that one.
Yes, it should be coming up in a second. Yeah, there you go.
I want to remove just the chat apps, if there is any. No, nothing. So we can go back.
I'll just give
this.
So
we're gonna strap me this.
just pop that over to you.
Like this.
It'll be that way. So you can do that. And if you can put that through your shirt if you want, or just clip it to yeah. Make sure. Clip it on there to your jacket or something. There you go.
Is it good now?
Yeah. All right, let's give a round of applause to Jesus.
Okay, so thank you very much for being here, and it's going to be a very nice talk of 20 minutes, condensing an hour in 20 minutes. So let's try to do our best. What I'm going to talk today is something that we've been doing for a long time, going through the ecosystem of DevOps and actually CI/CD and adding our expertise, which is in cybersecurity. So I'm going to talk today about a theoretical approach on how to framework cybersecurity into the DevOps lifecycle and the DevOps operations. So no coding, no apps, no vendor focus. Everything is agnostic, but it's totally oriented about, I know what you're doing today. I know what you're doing with Kubernetes, with Helm, with Docker, with all the applications. What I'm adding today is what some of you may know, may not know about cyber. My colleague, next speaker from Palo Alto, has the same view and knows a little bit about what I'm going to talk now. So let's start. So first thing is to understand that we come from, well, I come at least, you know, because I'm very old, even if I look young. I come from the old times when my first assignments in cyber were related to install firewalls. At the time, small firewalls, do everything with a console line. I configure at the time access control list and actually create rules on firewalls. It was very basic. From there, we evolved into what we use today, or what we're trying to get there, which is containers. We've gone through cloud, through physical, through virtual, but our idea today is that we want to transform everything that we have into a more efficient, less friction-oriented infrastructure and obviously deployment of solutions. So they wouldn't want to use virtualization because it's very heavy, it's only suitable for certain conditions, and more we try to transform what we're doing into a container, or eventually a microservice within a container, or get into serverless. It's not for everybody, it's not for all the companies, it's not for every size, but we are all trying to move there. Through that evolution, we got into discovering that what we used to do in the past, that was coding, became DevOps. So we had people doing operations, people putting infrastructure into place, people putting solutions into place, and we end up having this DevOps concept, which is a very old, but it's a new name because we like buzzwords. We need to make money, we need salaries, we need jobs, and people need to recruit people, so we need a new word that is DevOps. Are you a cloud specialist? That was 5 years ago, 10 years ago. Today, are you a DevOps specialist? So if you do a search for jobs, you're going to find DevOps and 95% in most of the jobs, even if they're not even related to what you're supposed to do. It was always there, but the idea is that we started having a lot of implication on infrastructure and technologies. In the past, we had very simple solutions into place, which implied a very simple security approach, or cybersecurity. Cybersecurity is another buzzword, because it was security from the beginning. It's just added the cyber thing, just to give it a very futuristic name. And it came from a non-organic growth model, which means development. I developed in the past, and you know how messy it gets. It gets really, really super messy. So it's very easy when you're alone. My first development started doing assembly in a Sinclair computer in Spain, at the times that we were importing those computers from the UK. So that was one person, one-man show. Today, when you're doing development, or you were doing development at that time, you grew into teams, and teams got complex, people have different views, and some of them had not even a single clue about what was going on at that time in the back end. And today, we are in a situation where everybody wants to get into DevOps, but we came from a monolithic, to a multi-layered model, multi-dimensional. We has a lot of implications. There's a very nice slide that you know already from CNCF that shows you how many solutions are in the market today, just for developers and for people involved into the DevOps life cycle. If we see the cycle, we see that there are many different steps that are all tied together. I know that you're tired of seeing that slide, but I have to go through it to get you to the point of how you put security behind it. You have to go through everything now. In the past, there were simple tasks, all of them split, and now into a cycle that we develop applications fast and we deliver them very quickly. That, from a security point of view, is a big issue, and it is a big problem, because we lost control of what was happening within a company or within an organization. If we look at the tools, and that's only a small capture of the tools into the cycle, you understand the complexity. Some of them I don't even know them, and I have never installed them, I've never seen them. Probably some of you may have tried all of them, but how long, how much time? And can you tell me, if you installed at least 20 or 25% of these solutions in your organization, did you acquire any security solution for that platform? So every time you did, for example, a purchase of a solution, did you acquire a collateral solution to secure that platform? I'm pretty sure that the answer would be no. Because some of them, people don't even think about them. Jira, as an example. Do you secure Jira today? Do you put an external solution, third party, to secure your operations with Jira? Do you secure your operations, for example, with Sumo Logic? No, sorry, not Sumo Logic. Let's put, for example, Chef, to make sure that you are actually securing that the content that goes to Chef is not actually some malicious scripting or some malicious written code. So when we look at that, people are just going forward and they're just adding. It's not you, it's not the security team. It's just that separated organizations are actually adding all of these solutions without your knowledge. Then we get to the point of seeing the picture. And that picture is even outdated because it comes from April. May. Sorry, my counting is going wrong. May. So this is already outdated because when you look into everything that implies anything related with cloud usage, you're going to find that there are new players. And we keep on going and adding and adding. I'm just going to tell you something that we may talk about it later when we meet outside for a drink. This is no longer sustainable. Even if you want to, this is no longer sustainable. There are too many players. The cake is too small, and there is not space for everybody. So at the end of the day, the reason why this is not sustainable is because they're not going to have the resources, the time, and the knowledge to push all their security improvements into these solutions on time. It's going to be all the time behind. The reason why we go into DevOps is because we want to build secure. We want to have code that is actually secured and is delivered properly. We want to ship fast. This is the most important point. We need to do fast, and we have to deliver it anywhere. We need to put it, finish it, code it, and have it. How many applications this morning where you wake up and you pick up your phone, either if it was an Android or an iPhone, how many updates from apps you had? Just this morning? 8. 13. You see, the number is just crazy. And it keeps on going during the day, and it keeps on going next morning. And if you were awake 24 hours 7 like a robot, you will have updates every time. Sometimes applications get updated twice a day. Sometimes they get updated even more a day as soon as they find a bug. This is very nice for us because we think as consumers that we are getting something nice and cool. But in the back end, there are a lot of security flaws and related with cyber that people are not taking in consideration. That's why then later we find out, oh, there was a leakage in data in an app, and we had the ability to extract data from a particular application with a third-party tool because they didn't consider part of the coding that they did not secure or that they did not check. So this is what happens, okay? That's a reality. At some point, somebody has to pay the price. We go fast, 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 and then we just keep on moving people. Okay, you're dead, next one. Then you're dead, let's push the next one. Okay, we think that the replacing people, that's a very nice practice, and say nice between quotes, in the cybersecurity space. As soon as something goes wrong, the first thing that comes into place is we need to fire people. Instead of finding the truth and the root cause of the problem, and then trying to educate the people. No, we just fire and replace by a new one, you know. Bob is dead, all welcome new Bob. So, when it comes to DevOps Sec, we have a lot of customer pain because the DevOps, okay, they have the problematic of having to increase security and compliance. The security is then slowing the people down a lot, especially today, with the complexity of the tools that I showed you before in the big slide, you know, with all the landscape. And then there are tools that potentially are incompatible or they are not even integratable. in between quotes, because that's not an English word, but you cannot integrate them. And then you end up having a lot of pain. There's too much time to prove that you're going to be compliant. There is a missing time to market. You're not able to get to the market on time. And then there is too much security. And when you have development teams that are reaching, like one of my customers, 300 developers in France, they are like, okay, we resist. We don't want you to bring any cybersecurity solution because we're not going to move, and if you push us and if they bring you into our cycle, we're going to get into bankruptcy. Well, that's just what they say, but at the end of the day, it's a question of changing the framework and the way of working. But that's their impression. And you go to meetings, and everything is resistance. And this is a big problem about cyber into the DevOps. So let's talk about the 3 different wordings that we have when we say DevOps and we put security into it. So we have the DevOps Sec. So the DevOps Sec is what we started doing in the beginning when we had for the first time DevOps, that we started bringing security at the very end. So at the very end, the only thing you can do is identify security risks of what you've produced or what you've, just given. You have the chicken. The chicken, puts the egg. We got the egg, and then we open the egg. The egg is dirty. The egg has a lot of infections. We got a lot of sickness. We need to check what's going on. But we already served the egg. So what we're going to do, we go back and we start thinking about patching. And we think about, let's look into how we're going to fix this. And that's called just putting stripes, into somebody who's unhealthy, who's sick. And what we do, we maintain the problem alive. We just fix it now. Put a hot fix. And then when the next one fix, put another hot fix. Get the guys to code a solution for the problem. But it's at the very end of the line. At the very end of the line, we are suffering, and the organizations get impacted. Then we get DevSecOps, which is what we are at the moment implementing. When DevSecOps, what we do is we actually bring, the development into adding security in that step. We develop with security in mind. It's very good, it's very suitable, because we get to analyze a part of the solution, a part of the problem, and then deliver a part of the solution. And this is the only thing that we are able today to apply in the real world, as per today. And then we get the solution, which is to do SecDevOps, which means that we're going to combine answers of cybersecurity and security, both of them. Security when we talk about, for example, best practices in the solutions that you're using, which is what I said before in some of the chats outside. The best practices about Docker, Helm, Kubernetes, etc. are actually today your job. If we were to work together and you came to me and said, I want you to help me, I want you to put the best practices into place, I will walk away completely. Because you're supposed to do all the best practices about the tools that you're purchasing and that you're using. All of them, all of the best practices books. All the controls, all the securities, all the encryption of the secrets, everything that we talk about was your job. My job was to add, in that relationship, extra levels of security that you did not see, that we're going to talk about just in a second. And SecDevOps means that we're going to start from the beginning. We're going to start taking the people who are developing with the people who are building security with the decisions makers, and we're going to actually put them into a framework which is processes, people, and tools. Some of the attacks that you can have in a CI/CD pipeline, that's part of the talk, is to tell you things that you may never heard about. For example, is the fact that as soon as you are vulnerable, you can have issues like, for example, fork bumps inside containers. Okay, so you can actually have an attack that generates a limited amount of processes that can just kill your container. That's one typical example. Can somebody tell me one of the typical exercises that you may have done if you ever did basic security training on Docker? One exercise that you always do when you do a basic security training in Docker that is totally related to this.
Scan your images?
No, that's way beyond, man. That's way beyond. That's actually what you should be doing as an extra level. The basic one in security, that they give you as a test to say, look how I can vulnerate a container, is to actually run a container out of memory by creating unlimited number of processes, or by creating a process that consumes all the RAM. So the idea is that because containers are containerized, you're supposed not to exceed the limits that you establish, so that you can use and reuse the resources. One of the typical exercises is, let's kill the container. I had access, the first thing I want to do is kill it. And how I do it? By just creating a process that uses all the memory. What can I do on top? Find any other container and do the same thing. And every time you create a new container, I'm just going to have the access and do that. That's a simple exercise. We can talk about it later. It's just few lines that you type and you kill it. Unwanted communication between unlinked containers. I got containers that should not be talking, but I find somebody who actually accessed and is able to actually start communicating between containers. You forgot to firewall the communication. You left everything as is. You forgot that there was a port open and you started communicating. UPT, unauthorized private traffic. Let me explain that a little bit better and not to waste too much time. Does everybody understand the phase 4 of an APT? Say no. No or yes. Yes, no, yes? So, an APT is an advanced persistent threat. It is used to mention two things. First one, an attack that's targeted to a big organization or a critical organization, or that is targeted to a nation, or that is targeted to a critical infrastructure. It's something that a team, usually not an individual, a team or / a nation does to actually vulnerate resources from a company, gain access to IP, protected IP or secret IP, or actually just take down systems. Like, for example, trying to take down a nuclear power plant, or trying to take down, this is not science fiction, or trying to take down a power plant from a country. That's very easy today. It happens probably every month. We hear a little bit about it. In phase 4 of an APT, one of the things that in phase 1, you do just the analysis of the target. You identify the target. In phase 2, you start with the point of entry, which means that you're actually getting a way to get into the organization by a mail, by a phishing mail, by a payload that is being weaponized, like an Excel spreadsheet or a Word document or a PDF that you send to somebody that you know that's going to click into it. The third phase is when you start doing reconnaissance, which we actually, at that point, you're identifying all the resources in the organization that you want to vulnerate and you want to have access to. And that's when you get into phase 2. Then you start moving laterally. Moving laterally or lateral movement means that you're actually starting to gain access to other resources in the organization. 1, 2, 3, from the machine that you vulnerated to the Active Directory server, to the SQL server, to the MySQL server, until you find the data that you're looking for. And that's the next phase. That's where you identify the data, and then you start with the next phase, which is actually exfiltrating the data. So the lateral movement is the unauthorized private traffic, which means that you're actually you vulnerated one of the containers, for example, and you're trying to use that container to gain access to other containers that are there. Rogue images. I gain access not to a container, I gain access to a Docker cluster. Worse than that, I gain access to the whole Docker things. What do? I drop images that you don't know that they are there. And I can spin them and run them as soon as you're not looking into, and run processes and run apps that you're not expecting to see. Or find images. That is something, I'm going to tell you a story. There was a military organization in a country where I went to do a project, and I asked, for that project there were many things to manage, and I asked for the management server, and the answer I got is, we don't have a fucking clue where it is. And we don't know, so what we're going to do is we're going to buy a new one. And that was like, I asked during many days, it was like, seriously guys, it said like, no idea. We don't know where it is. Must be somewhere, must be running, but we can't find it. So, you don't want to have orphan images running there that nobody's monitoring, that nobody thought that they were there, because then they can be used, they can be vulnerated, And then they can be just running there in the background with malicious processes. Rogue processes, it's very close to what we do in fork bombs, but the rogue processes are going to benefit me. So I'm going to run processes that you are not seeing into the container to give me some benefits. For example, establishing an FTP or using it, for example, to do SFTP or SSH to transfer files. Or I want to run a DNS server, so I'm going to use DNS to actually encapsulate other traffics inside, so you're not going to see it, because your devices are not supposed to analyze DNS and block it if you don't have the right devices there. And then I'm going to use DNS to exfiltrate data. Rogue libraries, that's the one I love the most, because this you see it very often. In the repositories, or even when I'm preparing my containers, in some cases what I do is, if I had the access, because we're talking always that I already got there, I put rogue libraries that I'm going to let the people use, while every time you spin your application that uses that library, the library is getting me an access, a backdoor. It's very simple for security, in big words, just to understand one thing. People want to have access. Don't get mad. The old times about destroying things is still there, but what people want today is to have access. And to have access without being caught, you need to run stuff that allows you to get in and to be in total communication with the machines that you have infected. So that's what you actually do. You put libraries that people then, when they spin them and they use them, backdoor, and back in. Every time you launch the container, back in again. Every time you launch another container with other apps that use the same library, I'm back in. That's a persistent attack. Persistent volume bounds, also, the PVMs, are giving me an issue if I'm not scanning what's inside those PVMs. So I need to look into that content to make sure that if they're persistent, I need to check what the content is. This is another one that we see very often, the cryptojacking containers. So what happens is that I attack a Docker host, and when I have access to the Docker host, I start spinning containers that are just doing crypto mining. And I use that to just crypto mine like crazy. Who's been ever infected by a crypto mining tool? Here. 1, 2, me too. So don't worry, we're all the same. So mine was CryptoJS. So I got infected just by going to a browser. At that time, there was there were no samples, so we had no way to block it, and my laptop just got infected. So I was crypto mining, for probably a few weeks before the pattern appeared in the security agent to detect that. So it's just normal. There's nothing, no shame about it. I mean, if there is somebody here who said I never got infected, I just don't believe it. So let's just take the mask off and say we've all been infected, and probably more than once. And obviously, we're talking about the APTs, which the APTs is the high level of the attack, it's the high conception of the attack, where we actually develop specialized malware attacks with malicious code, malicious payload, dedicated payloads, undetectable payloads, unless you have a certain set of tools, and even in some cases, it's so zero-day, zero-critical, the attack is so totally nearly undetectable, no patterns, no behavior to detect that we just get infected. And also, we have another problematic that will be the communications to command and control. So once I get infected, there are many things that happen. Either I'm infecting mass spread, so what I want to have is zombies all the way around, so I'm going to have my zombie containers talking back to my server where I'm going to tell them what to do. Or I have the other attacks where I just infect a target and I'm looking just to discover certain information into it. The CNC or the C2C communications is when you get infected and you're talking back to the master, to the person controlling those machines. These also, if you get infected with that, that is a more dodgy thing, but usually getting infected with the other things is pretty usual. By the way, everybody knows here a tool called Pod Player, a replacement for VLC player for media. Well, I just detected last week, after installing Pod Player, that one of the components, one of the DLLs from Pod Player is actually a spyware. So I got the full detection about it. So you see, probably Pod Player, I reported it, I never heard back. Yep, 2? What? 2 minutes. Okay, so I'm going to go fast. So how do we fix the issue? With frameworks, okay, that are going to be frictionless, that integrates with the code and the pipelines. that looks into detections in the early stages, so we're talking about the security before, that are continuously monitoring for the threats, that they're going to look into the historical activities, and we're going to be able to see what historically the activities are. Obviously, that they're going to lower the impact, and they have to be easy and fast to deploy. When we look into the CI/CD, we are in the different steps. I'm going to skip this slide to get into this one because it's much better. With some examples, when we are in the creation of our code and we are committing, okay, then we're jumping into Jenkins, okay, to build, as an example, and then we go into our containers in Google or in Amazon, okay? Or we're using the trusted registry from Docker. The idea is that we need to be scanning, okay, the code before. We need to be scanning what we're putting into the code, the files that we're using, the libraries that we're using, the code itself that we're using. I'm pretty sure that that is something that most of you may have tried to do, but it's very difficult. To get everything there, then scanning the registries, make sure that there's nothing rogue going around or something bad. Then creating an admission control, what is supposed to get into the final deployment and running. And then obviously making sure that when it runs, we find vulnerabilities and we find malicious files. Today there's three things that we're looking into. We're looking into protecting against the files, to see if there is malicious files with tools. We're trying to protect against, for example, vulnerabilities. When there are vulnerable containers, we need to figure out that there are libraries that are vulnerable or the components that are vulnerable that we want to replace, that we want to stop, to shield. And obviously get into the container host protection, which is actually installing a solution to protect the host itself. So that goes to the same thing. People inject malicious content either into the repositories or in the libraries that you're using, or eventually what they do is that people that use and reuse code for years don't realize that code has been infected and they just keep on pushing it automatically. This is one of also the big problems that we're facing. And the dependencies, because sometimes you're using something, you don't know that it's dependent, and you're carrying a virus with you. To mitigate them, vulnerability assessment, shielding, that's something that we now can do, actually, with the actual tools in the market. We're able actually to do that, to do the shielding, to stop it. Before we were able, and when somebody said that container scanning, okay, that was pretty cool. We've been doing that for a while, but what we do that is pretty important is that we are actually now shielding. So we are able to stop, like we are doing with the normal physical servers or virtual server or cloud servers. We're able now to shield and stop that vulnerability from being exploited. Continuously scanning, obviously. The immutability of our container is our key. We don't want the containers to change. And we need to get into the signature detection, the pattern detection, and the machine learning. And that's what's going to help us to add the new tools, the new cybersecurity solutions into the container ecosystem. And obviously, when we get to container, we talk about the CI/CD pipelines for DevOps. So that slide says exactly the same, and because I had 2 minutes, I'm going to use 1 more minute, and then I free you guys. It's just to give you what's going to be the future. So the idea is this is the last slide. So what's going to be next? Because the landscape is changing so much, and it's so dirty, because we have to accept that it's very dirty, it's not clear, it's totally, everybody's going in different directions, it's like a star with so many pathways. We need to actually try to think holistically and from a framework point of view. What do I need to put in place? Everything I can. How do I put it in place? The best I can. What about best practices? You should have done that yesterday. Don't talk about best practices today. You had them already. If you don't have them, you're not ready. You should not be even using containers if you're not applying best practices. So the mandatory things that you need to be looking into in the CI/CD pipelines is anti-malware and non-signature based. So we don't want pattern based. If it is there, thank you. But some detections that are not pattern based. We need to look into behavior analysis and monitoring. Thanks God, we got that already in place with different type of tools. We are able to do behavior analysis of a container and monitoring the different activities to figure out when there is a deviation. Machine learning and AI. If there are tools that give you a vision about this is a deviation based on how I learned from the past, go ahead and also put it into place. And obviously vulnerability assessment and exploit shielding, because that's going to be your problem in the future. In the next 5 years, the deployment of containers and microservices is going to be so big that if people don't put that into place, they're going to be looking at the early days of physical and virtual servers with no protection. And why? Because the sum of all the dev tools and the dev practices, plus the sum of all of the operations behind automation, infrastructure, etc., is so big, and it lacks all the security solutions and frameworks, the integration of them, the integrity of all of these elements. Thank you very much. That's the end. And if there are any questions, I guess there is no time, so we do them later.
You're welcome to ask, is it Jesus?
Jesus it
yes. Any questions during the break or after at the pub if you're going to be there?
Yeah.
We'll take a quick, I think we've got 5 to 7 minutes to waste, and we'll get next speaker up. Cheers.
There's more drinks and refreshments in there if you want to get.
Well, I've come the wrong way. Drinks and refreshments, you say? Okay. Well done. Let me put this here.
I think we know each other.
We do, I think so.
Yeah.
And also, it was good. I saw you on the emails. I was like, I think I know. Anyway, that was really good to speak to you. Oh, I'm sorry. Get rid of that.
Do you like it?
I did like it. I thought it was very good. Also, because what I really liked was you were very generic, like, and then the detail, boom, here's the detail. I really liked it.
Yes, because I said before, I'm totally agnostic.
Yeah.
Because 5 years ago, I started giving the early container talks, and they were so product-based because everywhere, and then people started just like, putting me the finger on the road, and you know what? Agnostic.
Yeah. That was excellent. No, it was really good. Thank you.
So, we're discussing with a few people from Palo. We're going to talk about that later.
Yeah, let's go for a drink later.
Yeah.
Let me get sorted because I'm worried that everything's not going to work. Yeah.
I'll grab that.
All right, thanks. Yeah, thanks, Sean.
That's why I said, like, every time I do this cloud native.
But it was when I saw your email, I was like, I know him.
I know you.
Yeah. And I was really pleased we kept it. It was still the same. It was like, oh, well, you pick. Anyway, sorry, Josh.
That's all right. So if you stick that...
Attention, please. Attention,
No,
please.
don't tell me.
The emergency is now over.
Thank you very much. That was brilliant. That was brilliant.
I was getting hooked up to tell you there was an emergency, but it's over now, so good. All right.
onto your bell.
Oh my God. Well, then we are all dead, and the emergency is over. Amazing. Amazing. Crazy.
You're welcome to stick that.
Sorry, do you mind a quick question?
Yes, go ahead.
Thanks for the talk, was amazing, very, very good.
Hear much, but
So, practical problems I'm facing at the
Practical,
moment.
okay.
So,
Let me sit down with you here. Okay.
And you've got the adapters and stuff already.
I have adapters, but I don't have the actual where the things are.
I've also got an adapter if you need it.
Fresh beer. The fresh beer. Rob, you're becoming my favourite person.
You want the hazy IPA, or do you want the...
Do you know what, the hazy would be nice if there's one about, whatever.
Yeah.
I have a Diet Coke, thanks, mate.
Diet Coke, here we go. Make it happen.
Yes, please.
Right, it does. Alright, now the only thing that I always fuck up, if you don't mind just staying with me for a second.
Do you need your
Awesome.
speaker?
I can live with it.
Fair enough.
I just always shit myself that they're going to be there and I don't know what to do with this. Thank you. And then I'll make sure this thing's working. And I'll be really happy.
I have one of them and they're magic.
They are magic. My wife went, how much do you spend on clicker? I was like, 30, 100. Alright, so we're good. And we're good.
Easy as. Fantastic.
Listen, thanks, Joe. And again, I'm sorry for interrupting you. I was just really stressed out because marketing been giving me a fucking hard time about stuff. You know what I think they've done? They've sent it to the other place. Literally, they went, we're sending all this stuff now. It's a meetup. Don't send this stuff. You know, those things?
Oh, no.
One of them, like a whole bunch of stuff. I'm like, please don't. Big company stuff. Anyway, I'll moan about that in a minute. But thank you again for helping me.
That's all right. No, but that's fun.
When am I good till? When's everyone come back?
They should be back in about...
give them some time. What do you need?
Look, you've got... I mean, normally it would be half an hour, running a little bit behind schedule.
Fine, I can do it short.
Okay.
What do you do? You're sitting right there.
Yeah.
Give me a 10 or give me a 10 and then give me a 5.
Yeah. Sure. Alright, easy.
You're fine with that.
We'll just wait for everyone to come back and I'll introduce you.
Cool.
Josh, I have to get going because I landed back at like 5 AM on Sunday, right? I'm still on Sydney time.
Alright, mate.
You know it's bad.
Signature. Let me know when you sent over.
Diet. Yeah, I will.
Is that diet?
It's the diet hazy IPA.
Appreciate it.
He seems to be the one that's had
Cool.
Awesome. Cool. See you.
See you later. Your accent's not English, is it?
No, it's Scottish.
Scottish, yeah.
Although it's, I lived abroad for a while, so it's a bit of a fucking accent.
I'm Australian, so I'm still getting the accents.
Well, mine's a very difficult one to get, so you did well. Anyway. Yes, sir. He's from New Zealand, so he's got a chip in his shirt. The green and the gold. He's from South Africa.
He's from the worst Australia.
He's the bad bit of Australia. He's from the good bit. Is there a good bit? I mean, I don't know.
It's all bad. It's all bad. Sorry? Yeah, exactly. All right.
Right, do you want me to start?
Yes, please. Yeah.
Right, and back this way.
Thank you.
Yeah, that's a really good metric. When someone goes,
because of the time.
So have you been with Twistlock before the merger?
Yeah, I was the first in EMEA. I was number one technical, in fact, number one anybody in EMEA for Twistlock. So that was a long time ago. It was a good 2.5, 3 years ago.
Yeah,
oh, right back.
Yeah. Back when you were my age.
You probably don't remember. That's how long ago it is. Yeah. So then it was about 3 years ago, and I was first in EMEA, and I was Twistlock through and through, and now I love Palo Alto.
That was a very that was convincing.
No, it's like your Max. Yeah, no, it's like
Oh dear.
In fact, I'll need to remember and use maximum efficiency at some point when I do
Maximum efficiency.
Yeah.
So do you live in London or?
No, I'm up in Scotland. Yeah. Well, I travel a lot, so I'm around all the time. But yeah, I'm up in Scotland.
Edinburgh?
Halfway between Edinburgh and Glasgow. But Edinburgh, yeah, basically.
I was up in Edinburgh a little while ago. I think we're gonna see if we can. I think we're thinking of driving up to Inverness for Christmas.
Okay, because I was going to talk about something completely different, which is the Cloud Native meetup in Edinburgh. It seems to have shut down.
Oh, really?
And I was looking going, well, you guys are really active. I mean, really active. You've got no speaking starts till November. There must be a way of going, all right, fine, well, I don't know, but it just seemed like, Scotland's not that desolate. There must be a way of getting all the stuff we're doing piggyback onto it, or just, it's part of a community. Anyway, that's by the by. We'll talk about it.
It is difficult. I also run the one in Cambridge.
Oh, yeah.
And even that, it can be difficult to get people from London to come up and speak and stuff.
That's annoying, but you must have good attendees at Cambridge, just the thought, or is it?
It's about 40 to 50.
Yeah, okay.
It's not too bad.
That's all right. Anyway.
Hopefully everyone should be getting close
So,
to it. Should I introduce you as from Palo Alto or from Twister?
Yeah, you put up the board. Do Palo Alto.
Okay. Formally.
Or whatever.
Palo Alto Twistlock. Are we? All right. Cool.
All right. Well, we'll see how it goes.
All right. Hello.
All right, so we'll. Looks like pretty much everyone that's going to. Everyone's in here. So next up, we'll have Ashley from Palo Alto Networks, formerly Twistlock, speaking about the age of cloud native security.
Lovely.
Fantastic. Round of applause for Ashley, please.
Thank you very much. I take particular pride in walking past the signs that say no food and drink in the auditorium. So that's always a big pleasure. So there's some good news for you all and there's some bad news for you all. Jesus is fantastic. I was really pleasured to be in the email chain about us coming and speaking here, and I was like, that dude's pretty cool. And then of course he does his stuff, and you're like, that dude is really cool. And I'm following that. And I go, well, I disappoint my children, so disappointing you isn't a big deal for me. And more importantly, actually, the slides were put together by marketing, but the best bit is I'm kind of drunk. So things are going to go as they're going to go, right? We'll all have a good time. And it's been recorded. Ashley Ward previously worked for Palo Alto Networks, because after tomorrow, I'm not going to work for Palo Alto Networks anymore. Okay, so yes, Ashley Ward, who am I? Because we've all got to do the who am I stuff. Well, I am Ashley Ward, have been for a long time. Thank my parents for that name. So Ashley Ward, I started out life as a Unix admin, then migrated into Sky TV and did some stuff there, infrastructure architecture, some DevOps stuff, very cool, look at me, and cloud stuff in Aegon. And then I actually brought, I was doing a whole lot of stuff with containers, which is where my passion lies, and I ended up evaluating Twistlock, picked Twistlock, ran with Twistlock customer, then came, like Gillette, like the man from Gillette, I bought Twistlock. I thought it was so cool, I bought the company. Well, I didn't have the money, so I didn't buy the company. I went and worked for the company, so then I went and worked for Twistlock, which was nice because it got bought by Palo Alto, which meant that I got flipping nothing. But it was nice. Anyway, so Ashley Ward. I'm at a cloud native meetup, so I would imagine that you know about cloud native a little bit. The big thing, and honestly, I laugh at myself and I try and make things funny. I know I'm not funny, but I try to make things funny. But this is quite serious. So about cloud native, what's very fantastic about the Cloud Native Computing Foundation is not just about taking on different projects. We saw the slides. Jesus, where are you? You had all the slides there. That's fantastic, all the different things. But it's about democratizing, and that's a word that's in the manifesto. I'm sure you all know it. It's there. It's about democratizing this so that people can do it and use it. Now, I did mention about how marketing put the slides together. I am a paid employee. I am a vendor. I am probably worse than Satan. I accept that. So what I'm going to try and do, because I'm getting to have a drink and just talk, we're trying to look at this not from a vendor-specific point of view. Yes, I'm a vendor. Yes, it's specific. Yes, I'm a salesperson. I get that. But actually, I don't believe you need to... this isn't a Palo Alto thing. Although, you definitely should buy Palo Alto Networks. A wonderful product and all that other stuff. But please look at it as there's more than this. Okay, so Cloud Native, you've read that. Hopefully you've read that. If you've not read that, then you'll be tested on it later, okay? So you better have read that. What have we got? Well, Cloud Native, stuff is happening, marketing, love that. Next. Now, what we have here though is, and this is where I get to do something, and this is where my wife, God, I hope this is recorded, my wife laughed at me when I bought this for £100, but when I do this, it jumps everywhere, it doesn't work. There we go, look at that. There we go, that's it, worth it. Okay, so what I want to talk about is actually these three things. Broadly think of 3 layers, and this is what you need to think of. So cloud native, I'd imagine everyone in this room is very au fait with cloud native. What we're trying to do, we're trying to deliver better things faster and more consistently, right? It goes back to the Agile Manifesto. It goes back to even just actually making computing available for the masses. What happened? XP. What was great about XP over 3.11? It was pretty. Okay, there were some other improvements, but it was pretty. People could use it. What was great about the iPhone over all the other things that I played with, all my PDAs and everything else? It was pretty. People could use it. It was accessible for people. This is the big change. So everyone talks about developers, DevOps, the new kingmakers, how we do all these kind of things. But what is it that's important? We're making things accessible. We're democratizing. And as much as I think that's a wanky word as anybody else, we are democratizing things. 3 layers. This is what cloud native computing is. You have physical. How the non-sweary way do I cool these computers? Because they're hot. They're hotter than iron per inch. Oh, I shouldn't say per inch, per millimeter of something. They're hot. Service, all this kind of stuff. I mean, genuinely, though, we've got these different layers. We've got the compute, we've got the service, and we've got the stuff that you do. Continuum of compute choices. Now, actually, Jesus is somewhere. Is he here? Is he gone? Are you about? Where are you?
I'm here.
Ah.
I'm besides my jacket.
Well, how did you get better looking when you stay up there? Oh, man's a god. So one thing I do disagree a little bit with you, and this is why I'm calling it out. One thing I do disagree a little with you. I don't, and marketing, obviously, because they did the slides, so then, you know. But I'd also agree with them. This isn't a journey to here. You don't have to be pushing to serverless. This is actually a continuum of cloud native security. I always think of continuum transponder, which is actually from a movie. Kudos to anyone who knows that movie. But there's workloads, right? So remember when it was only 2002 that VMware came out with the server product. Virtualization as a server product only came out in 2002. You're having a laugh. But that's what happened. The iPhone was 2007? So 2007. Somebody knows it better than I. So brilliant. So this idea of, oh, everything has to be serverless. Yes, I mean, I've drank the Kool-Aid. I like this bit over here. I think it makes sense. I think that we could actually commoditize serverless functions. I think you could sell serverless functions to people. If you've got some good ones, you could sell them to other companies. Realistically, though, this is a continuum. There's going to be some stuff that's better in VMware and, virtualized machines. I didn't mean that as VMware. VMs. And it is about isolation, compatibility, control. I have arguments, people very frequently who go, oh, well, containers. You're sharing a kernel, aren't you? So that's bad. Well, it's not necessarily bad, just the same way when you've got a hypervisor there. Isn't that bad? No, because it's this. Well, fine. Go away. Do that stuff. And the same thing, right? So there's a very valid use case for using VMs. And if you're running Oracle, there might be a very good use case for actually using a physical machine, because actually you've got to justify your cores and do everything else that's there. But so that's fine. This isn't a journey that you have to get to that end. This is about isolation, compatibility, control. Isolation, compatibility, and control. And at this end, thank you. And at this end, density, agility, simplicity, simple. See, okay. But the thing is, it's not about you have to be at one end or you have to be at the other end. It's about everybody who's doing anything in IT knows now that we have different workloads, we have different business deliverables, because ultimately, and this kills me all the time, we're doing this for a business. We're not doing it for fun. If we were doing it for fun, everything would be awesome. We'd be sitting here going, by the way, did you see how I totally did this? Yeah, it was amazing. Instead, did you hear about so-and-so who got sacked? Why did they get sacked? The project got shut. We're doing this for actual money, for real reasons. So, cloud native makes I thought you were going to join in. All right, fine. Okay, cloud native makes compute security harder. Well, this is actually a thing that comes up very often. So remember, this is me as we're in a top doing a sales pitch to you to say you need to think about cloud native security, which is something that Palo Alto Networks does very well. But actually, what I'd like you to take away from this is that I think we're all looking at things from a cloud native perspective, right? So we're all looking at delivering software faster, with a better quality, all the stuff that was said before. We might be looking at it in an agile way. We might not be. There'll be people here who might be saying, well, we don't. We do things in a waterfall methodology because the Ministry of Defense demands that, because the nuclear industry demands that, because of whatever business reason. There are business reasons why we all have to make difficult decisions. Technology is not there for the sake of technology. So what I think from a cloud native point of view that we want to look at, especially when it comes to security, is that these are things that make it tough. Okay? And you need to think about that while I do this. Did you no, you didn't think about it. You've thought about it now? Okay, you've thought about it. Okay, but these are things that make it tough. Oh, for God's sake! These are things that make it tough. So you did all think about it there, yeah? Yeah, okay, there's no interruption here. We're all still doing the same. Okay, there we are, we're back on board. All right. So, but actually, we can do things better. And the reason why we can do things better, and I had this discussion today with somebody, is that back when Ashley, me, in case you forgot, was a young man. I know I'm still a young man, thank you. But back when I cut my teeth as a Unix admin, I reckoned I could manage about nine machines. And these were big Solaris machines. Some were Fujitsu, some were IBM, because I'm, heterogeneous. But they were big Unix machines, right? And I reckoned I could do 9 of them at one time. I mean, not if they came at me with knives, but I could manage 9 of them. And I could know everything about those 9. So that if something went wrong, I would know immediately. And I could manage those. Now, bear in mind, you're all looking at me going, what is this idiot talking about? Well, no, for this particular part. The rest of it, yes, idiot talking. But this particular part, well, that was because that's how you manage systems. You had someone who had root access, who managed the entire system, and you might deploy an application, but your application can get to, I'm from Falkirk, so get to Falkirk, versus the server. Okay? Because the server was more important, it was more costly than everything else. The reason why cloud native comes along is because you can say, well, actually, it's declarative. So all those fears that I had as a Unix admin about whether your application was good or whether it met compliance or whether it did whatever, it can all be declared. And this is where we're coming to, and this is as we go through, hopefully you'll realize it's not just a marketing sales pitchy thing here. I'm trying not to do that. These are things you can do. You can, if you're operating in a cloud native way, then it's automated, it's declarable, and it's well, should be immutable. And also these words that are there. Compute is one of the layers. There are layers. The big thing that we have, or that I found speaking to people, now, as I said, I was in an operations background, so everything, there was no cloud, just someone else's computer. You don't touch that. But these are the things where you turn around and you go, well, okay, if somebody else is a shared responsibility model that says that they will manage everything below this point, that does mean you need to manage everything above. Now that changes if you're moving from a data center into a cloud native world. Now, I say cloud native, and I kind of feel a little bit embarrassed about it because, of course, these slides are slides for everybody, slides for enterprises. And actually, when I'm talking to a room like this, people are going, we already know cloud. We're already bought in, we know shared responsibility, that's not a problem. But it's actually things like, you might say, well, these things are port controlled, and so these are security groups, that means that's defined. That doesn't necessarily mean that's defined. You still need to audit that's what's happening. If you've opened 53, is it only DNS traffic that's going over there? Or have you got someone doing an SSH tunnel? How do you know your environment? Damn it. Marketing beat me to it. I tried to say that, and they've already done the slide. Didn't do this slide though. So this one here, this is where we're moving into all the things you need to worry about. This is still their problem. The hardware, the data center, the cloud that you're operating in. And if you're doing cloud native internally, in an internal a scenario where you've got infrastructure as a service or any other type of service, that's probably an internal IT team, or it should be. The stuff above is still there. You still need to know that everything's secure around that. All the stuff you need to manage is still there. Now, we've got their source component analysis, which I laugh at because, of course, that's not something, this isn't a sales thing. We don't do anything like that. Palo Alto Networks don't do that kind of thing. They've got a whole lot of stuff with shift left. But think about it. If you're doing cloud native development, hopefully you've already looked at, well, we want to lint the code that we're writing, or we want to check it for quality. We're going to push that through. And remember, this isn't Agile Manifesto. This is just DevOps stuff. This is about, well, we're going to automate as much as we possibly can. As long as if shift left, 10 minutes. You couldn't just hold up your fingers. You had to write 10 minutes and embarrass me like I'm going, and now I'm talking about it, which is making it worse. Wow. Okay, well, that's fine. Well, then, you don't need to know about that. Good, cloud native security platform. Okay, what is it? Well, what it is let's all group all these things together. So Gartner have all the, it's £10,000 to be a member of Gartner to get their nonsense. Good stuff, their interesting insights. I'm just jealous. I'd love to charge you all £10,000 each to listen to me spout off about stuff. So Gartner have some very deep and interesting insights in a number of different areas, of which we're very proud to be a part, and I'm sure that, but some or other. But what is it? Well, it's all about the security. So if you are doing, that's fine. I've got 20 minutes and 53 seconds left. I've had that for the last hour, I think. So there's a timer there, tell me. So the big thing about this is cloud native security. What does it mean? It means that you need to consider every aspect from that shared security model up. It shouldn't be a frightening thing. It shouldn't be something that's awful and everybody goes, this is terrible and I hate it. It should be something that we're all able to do. Yes, DevOps was always DevSecOps or DevOpsSec. It was. Non-functional requirements were always part of DevOps. Admittedly, though, if you're delivering the dev part, you're delivering business benefits, so it's always going to outweigh the operational part. It is. It has to. The operational part is still very important. So, CNSP, people can do this stuff. I'm on a 10-minute warning. I've kind of lost the will to do this now, to be honest with you. I just, why, though? Okay, so obviously there's the Palo Alto Networks do that. I've got the top one. What you need to look at, if you're doing cloud native development, which you all hopefully are, how do you secure that? The way you secure that is by making that part of your development cycle. If you have a backlog that says we're going to deliver these features, we're going to do this or that, the next thing, then you need to build some security in there. If you have to offload your cloud security to another team, or another tribe, or another area, another squad, that's fine, that's cool, that's all great. But be aware, you are missing out on some of the security features, which are where did it come from, what does it do, how do I secure it does that, and also, if we're all operating this cloud native, don't you dare write down 5. You just, but if we're all operating this in this environment, though, we automatically exclude people from how we're operating. So if you are developing fast in a cloud native way, which hopefully we're all here, cloud native, that's what you're doing, you might have an organizational structure that enables you to do that. You probably also have an organizational structure that is against what you're doing. Now, either your organization is going to be change averse, and you're going to have to fight those antibodies that are trying to shut you down, or they're going to be open for change, but you're going to have traditional security and compliance regimes that want you to do certain things. There's that. Certain things. Maximum efficiency. But want you to do certain things. And that's where, this, and look, he turns around. I was actually almost professional. Actually, I'm quite pleased with myself. This ties in. But this is where, whatever security tooling you're using, you do need to look and go, it needs to be easy for your developers to use. They need to know this in advance before it does anything. But they need to be able to call it via APIs. Why? Because everything's API driven. I do not want a vendor to give me their dashboard. Oh, it's a nice dashboard. Yeah, sure, it's a nice dashboard. I've got 1 million of them. We need to be able to consume these and run everywhere, and we have a rocket. You can't argue with that. I'd like to see somebody argue with that. All right, I actually have no idea how many slides I've got left, so let's just click. Old world, new world, we've talked about that. Oh, no, let's go back. All right. No, the thing is, if you look at everything that you're doing from a cloud native point of view, and if you look at things where and I hope this resonates with a lot of people, there's sometimes different silos or different worlds in an organization. One of the ones that's always the slowest to react, because they do such a good job, I work for a firewall company now, so, but the firewall people, right? It was always, to me, it was always, we've developed this thing, we're going to make this thing live, now I need an SSL cert. That's a 2-week. I need to go back a few slides because I don't even know where I was. You've just put me off. You just put a sign up that said 30 minutes. I don't even know. Was that metric minutes or imperial? Okay. So, right, stop it. Right. If you're doing your cloud native development, you're cloud native, you guys, you crazy kids in your cloud native development, if you're doing stuff though, we all need to realize that there is a reason why we have non-functional requirements. There's a reason why we still have the silos, even though we don't want silos there. There's a reason why people develop things like tribes and squads and develop them lines. Why? Because there is still a very serious reason for having operational risk and operational control over things. Now, I'm the same as everybody else. Look at you writing 30 seconds. I'm totally bought in. I'm completely agree that we should be in a position where we can deliver fast, deliver often. Please, please, please do that. And please, please, please think about how you can build security into the whole life cycle. Also, you can totally buy Twistlock or anything. And if there's any questions, then great. Otherwise, let's all go get a beer. Thank you.
Thank you.
Oh, let me write 3 minutes for you.
Thank you, Ashley. That was...
It was what?
Different. No, it was...
half that bad.
That was very good. That's the time, by the way. Like the actual time, not the time left.
Not time left. That's why I kept going up. Yes. I was like, they must really like me. They keep on pushing up.
All right. So, in terms of pub, we're going to head down the road to the Inn of Court. It's not far from here. So, if you can make it, that'd be great. Otherwise, round of applause, please, for Ashley. And that is us for this year. We will see you in the new year. Thanks, everyone.